Hello, this will be the remake of the Invitational A 2023 number sense guide. The last video was pretty gosh darn terrible, so this time I decided to write all the answers in the blanks to make things easier to follow and write my methodology so the things I'm talking about makes more sense. Let's begin. I'll also be going a bit slower, well, a lot slower, let's be real, than I did last time. 2023 times 4. This can be solved by splitting apart the things you're multiplying by. You can multiply 23 by 4, and you get 92. Then you can multiply 2000 by 4. As you can see, this is basically just distributive property being done. So 8,000 and then 92. Okay, 1 over 2 divided by 8 over 5. You're dividing, so you have to flip the fraction. 1/2 times 8 over 5. 8 and 2 cancel out, and this 1 is kind of irrelevant. So now you just have 8 over 2 over 5, as I talked about, so 4 over 5. You can instead, the easiest way to do this is act like you're subtracting this number from that one, because this is the one. Oh, I forgot to put the negative sign there. My bad. There you go. I did, and I forgot to change it back. Okay, so what you do is instead you act like you're subtracting the larger number by the smaller number. And then you have to make it negative at the end because the negative number is bigger, basically. So in this case, you just subtract this. You can use basic subtraction tools you learned in like 4th grade. Add 10, take 1 away from that. 12 minus 6 is 6. Now this is a 2. Add 10. 12 minus 3 is 9. Subtract 1 from that, 3. And then you make it negative. 4 is pretty simple. You just add each digit together. Not too bad. Don't think I need to go into too much depth on that. 31 squared. 1, you should probably already have this memorized, but if you don't, there's a way you can think of it as 30 plus 1 squared, which using FOIL will get you 30 squared plus 30 times 2 plus 1. So 900 plus 60 plus 1 is 961. This percent is equal to 85 over 100. Divide numerator and denominator by 5 to simplify. 25 times 16. 25 is 100 over 4. So 16 over 4 is 4. Multiplied by 100 to get 400. 8, this times 10 power to 2 plus 1. This 10 power to 2 moves this decimal over 2 places. 2023 plus 1 is 2024. 9, 7, 14 divided by 7 divided by 2. You can basically, if you don't know how to do 714 divided by 7 easily, you can imagine you're splitting the number you're dividing by. 700 over 7 plus 14 over 7. Distributed property of division, yada, yada, yada. This is clearly 100. This is clearly 2. So now you just have 102 divided by 2, which is 51. Okay, 10. These are the important parts. This isn't really relevant. These are pretty close to 31, so 31 or 310s. You want to ignore the zeros on these estimation problems until after you finish. So 31 squared is 961, and then you ignored 2 digits, so you have to add them back. So 961 and then 2 digits from the ones you ignored in your multiplication. 75 times 75. Okay, since they both end in 5s, you can use a specific trick for this, where you square 5 and write 25 at the end for your 10s and 1s place. And then for your place before that, you do 7 plus 1, or 7 times 8. Uh, that's not... Okay, I think I tried to write something and then I forgot. 17 times 80, I suppose, or 7 times 8. It's consistent with my other formats I did. So yeah, Brian Heath booklet. If you want proof for that trick, you can ask me. Brian Heath probably has an example, or you can prove it yourself using distributive property. I'm not going to be proving any of the stuff in here. That's something you can do on your own time if it helps you remember it. Okay, 3 power to 0 is 1. 3 times 3 is 9. minus 3, 6, plus 1 is 7. Which is larger? Well, this number, bigger numerator, smaller denominator, it's clearly larger. 12 square feet to square inches. To convert to square inches, you multiply by your conversion squared. So 12 times 12 squared is 12 cubed, which you should have memorized to be 1728. Well, okay, this is the sum of the arithmetic series problem. So to get that, you take this last number, multiply it by that last number plus 1, and then divide by 2. Because you can imagine the entire, no proofs. Like I said, I got to finish this within a reasonable amount of time. You know what? Fine, I'll do it for this one. Imagine the entire series backwards. So 39 plus 38, and then adding each corresponding term, you get 40 for your 39 terms. And then since you added the same series again, you have to divide by 2. Okay, 16. This stuff divide by 4. Basically, the remainder when divided by 4 is only the last two numbers. The remainder divided by 4, so 2 mod 4. Oh, I may have forgotten to show you. I'm going to be using this symbol. This means mod or the remainder while dividing by the number. In this case, the remainder when dividing by 4. So this is clearly 2. This is clearly has a remainder of 1. 2 plus 1 is 3. You can apply this remainder thing before you add it together, by the way. You can apply it basically whenever you want. Okay, add these together. This is 15 times 72. 15 can be rewritten as 3 over 2 times 10 to make it easier. So 72 over 2 is 36, times 3 is 108, times 10 is 1080. 8. Oh, did I just, I forget, no, I did it. I just forgot to put the answer in. There we go. Okay, 16% of 6 is what percent of 48? Well, 48 is 8 times 6, so an appropriate percentage would have to be 8 times smaller than 16. So you simply do that proportion, 6 over 48 is equal to 8 times your original percentage of 16 to get 16 over 8, or 2%. Okay, 19, difference of squares. Difference of squares is the sum of the two values times the difference between the two values. So 80 times 4 in this case. And then you divide by 2, multiply by 2 to make it fit this format right here. Okay, another estimation problems. These are a little hard to explain, but I'll do my best. You can see this number is like approximate. We'll be ignoring excess digits that are close. And basically, anytime there's a 0 or a digit that doesn't really matter, I'll be ignoring it until the end. So you can imagine this as 22 times 8 to get this 176 right here. It's a little less than that, so you don't want to put quite 8, put like 7, 9. And then you have to figure out how many digits you still need to put. Well, this 7 point something times this 2 point something gets you this 17 point something. And there are 4 digits after 17, 2 after the 2, so that all has to be 2 after the 7 for them to add up to the same number of ignored digits, I guess you could call them. The LCM of 24, 48, and 80 is what? Okay, this 24 is irrelevant because the LCM 24 times 2 is 48. So for something to be an LCM of 48, it has to already be a least common multiple of 24. And that's what it means, least common multiple. So what you do instead is you can ignore that 24 now. You find the greatest common factor of 48 and 80. In this case, that value is 16. And then you do the two numbers multiply divided by that GCF. So to make the multiplication easier, 48 over 16 times 80 instead of 48 times 80 over 16. Now you just have 3 times 80 is 240. Okay, 72 times 15. We went over this earlier. 15 can be rewritten as 3 over 2 times 10. 72 over 2 is 36, times 3 is 108, times 10 is 1080. 23, just plug in your values. 48 over 4, just plug in the appropriate values you've given. This equation right here is the equivalent of x squared minus 2 all squared. Because you could think if this was squared, this was singular, it would be x minus 2 squared. But everything's multiplied by x again. So basically, yeah, just x squared minus 2, it squared. You can clearly use distributive property if you want to map that out. But this is 16. This is minus 2 is 14. 14 squared is 196. Simple interest on $800 at 8% for 3 months is what? 3 months is a fourth of the year. So this 8% divided by 4 to get the total interest of 2%. And then 2 over 100 to convert to an actual fraction. 2 over 100 times 800. 800 over 100 times 2. 2 times 8, 16. And then remember the zeros. Okay, bases, base 7. How bases work is this is 1. You can imagine in base 10 you have your 1s, then whatever this digit is multiplied by 10, this digit by 10 squared. So it's similar. This is multiplied by 1, this is multiplied by 7, this is multiplied by 7 squared. So 49 times 2 plus 7 times 1 plus 3 is 108. Okay, 57 times 57. This case, the tens place add up to 10, so you can use a special trick. To figure out the last things, you square this 7, or you multiply these two numbers, 7 times 7. Or, okay, it's the fact that tens place add up to 10 and these two numbers are the same. 7 times 5 plus 7 times 5 is 7 times 10. It's just 70, so this part of the equation is ignored for basic, you know what? Yeah. I can't explain proofs very well when I'm not in person, so I should really stop trying. But basically, 7 squared, write 49 at the end, and then you have your 5 squared plus your 7 that's in your ones place to get 32. Okay, 28. This divide by 101. Okay, for that to be the case, you're guaranteed that the number sense basically guarantees these are not going to be mixed numbers or improper fractions or anything. So for you to get 2, for some number to multiply by 101 to get this number right here, the last two digits must multiply to get 2, as you can see here. So 2 times 1, the last digit must be 2. Similar for here, for this to be a 3, this 1 must multiply with the tens place to get a 3. So there's a 3 in your tens place. And then for this 3 right here, that is equal to this 1 times the hundredths place, plus this hundredths place times this ones place. 1 plus some unknown value, plus 2 times 1 is 3, so you have a 1 left over there. Okay, this is basically 2,000 minus 4 times 4, and then the 4 times 4 is given back, so it's just 2,000 times 4. Okay, next, square root of this stuff. You can take the square root of each individual thing and multiply them. Square root of 256 is 16. Square root of 145 is approximately square root of 144, which is 12. Just multiply them together. You can use distance from a common square. So 14 squared, which is the average, and then minus your distance of 2 squared. So 192. Okay, multiplying fractions. In this case, you want to multiply the whole numbers. 8 times 4 is 32. Then you want to count for the fractions. So 4 over 4 times 1, add 1, get 33. 8 over 4 times 3, add 6. What was I on? 32, 33, and then 39. And then you multiply your fractions to get 3 over 16 as your mix. 39 and 3 over 16 as your mixed number. 24 asks how many positive integral divisors. How to figure that out is you write everything in terms of primes powered to some number. So 24 is 2 powered to 3 times 3 powered to 1. And then you take these powers right here, 3 and 1, add 1 to them, so 4 and 2, and then multiply them to get 8. If you are curious about any of the proofs, though, I can prove almost all of this stuff in person. It's not that I don't know how or just want you to memorize it. I just don't. It's just hard to explain proofs on a online screen without your feedback. So 5 times 6. This is similar thing, same thing as you did on 31. 5 times 6, 30. 6 divided by 6 times 1, 31. 5 divided by 5 times 1, 32. Your whole number is 32. Then multiply the fractions 1 over 30. Smallest root of that is what? In this case, it is 2. Okay. So, yeah, why I gotta talk about y, duh. First off, you can notice this is x minus 2 times x minus 3 if you want. Alternatively, you can use quadratic formula. So I recommend you do your square root stuff first. B squared minus 4ac, 25 minus 4 times 6 is 1. It's the smallest root, so you're subtracting that value, negative 1, minus negative b, so plus 5, and then divide by 2. 2 times 1 over 2a, you know. You know the quadratic formula, you got it. 2. Okay, that many dogs bark at cats, that many at birds, and 9 bark at both. How many dogs are there? This basically, I'll just tell you first off, something that you can remember if you don't want the logic behind it. Number barking at one thing, number barking at another thing, add them together. It's equal to the total number of things plus the total number of things barking at both. So basically, 22 plus 17 is equal to 9 plus x. 22 plus 17 minus 9. And then you get 30 for that. And that's because this 9 basically acts as the amount of dogs that are being double counted in here. So you got to subtract 9 to counteract that and get the total number of dogs. 36, remainder stuff. Okay, you'll want to do the remainder on every single one of these numbers and then do the math. 14 divided by 4 has a remainder of 2. 10 divided by 4 has a remainder of 2. And 73 divided by 4 has a remainder of 1. 2 times 2 plus 1 is 5, which has a remainder of 1. How many integers between 3 and 33 are relatively prime to 33? We'll use our equations for relatively prime numbers, which is take all the prime factors again, write it as that prime minus 1 over the prime. Do that for each of them. So 10 over 11 times 2 over 3 multiplied by original value. Since every integer or prime divisor only appears once, you can basically cancel out this 3 and this 11 to just get 10 times 2 is equal to 20. And then 1 and 2 are relatively prime because if you don't know what relatively prime means, it basically means the only common factor between them is 1. So 33 is not divisible by 2, and 1 is relatively prime to everything. So 20 minus 2 is 18. This is a sequence of primes. 13, 23, 36. This, you can simplify this as 6 over 3 all squared, which is just 2 squared, times 1.5 squared, so 2 squared times 1.5 squared, which you can combine again. 2 times 1.5 all squared to get 3 squared is equal to 9. This may sound like a lot, but as you get better with number sense tests, you'll start skipping some of this test and you'll go from basically how I would do it is, okay, 2 squared times 1.5, 3 squared, done. That's how I would do it. So I'm like skipping some of these steps in my head to do it quicker. 40, ignore stuff and round them to stuff close. 14 times 14 times 40, slightly less than that. Well, 14 times 4 is 196, which is pretty close to 200. So 2 times this 4. Now we're a decent bit over, so let's subtract a bit to counteract that again. 78. And then once you do that, you have to figure out the number of zeros to write. So you can imagine this 3 times this 1.4 times this 1.4 gets you 7 point something. So now you got to count the number of digits after each of the highest place. Or so we basically did 1.4 times 4.0 times 1.4. And we have 5 digits we ignored. So you have to add the 5 digits after the 7. Explanation problems can be pretty hard. If you want a better explanation, ask me in person, all that stuff. The 1 cubed and 5 cubed are the same distance from 4 and 0 respectively, which just means they cancel each other out. Uh, Alternatively, you can just do 1 powered to 5 is 1, And then 3 power to 5 is 243 divided by 4 as a remainder of 3. So 1 plus 3 is 0. Math, remainder math. So you can also do that. I didn't actually write 0. I didn't write this either, but 0 and 55. This is 6 squared minus 1. Basically, that's 36. So in base 6, it would be 100. 6 squared, and then your 6, and then your 1. So, and then you're subtracting 1 from that, so 5, 5. Because the last digit on a base 6 is 5, because the last digit on a base 10 is 9. It's the base minus 1, basically. 125 is how many positive integral divisors. We do the same thing. Find the each prime, power it to each exponent, and then multiply them all together. Well, multiply that exponent plus 1 altogether. Well, you just have 3 plus 1 is 4 for this. So 4. In specific, the numbers are 1, 5, 25, and 125. Let k be the smallest three-digit number divided by 6. Find k. Well, k, for it to be divisible by 6, has to be divisible by both 3 and 2. And the smallest three-digit number that does it is 102. Because divisible by 3, all the digits add up to something divisible by 3. 1 plus 2 is 3, which is divisible by 3. And then if it's even, it's divisible by 2. Okay, 103 times 102 is what? Basically, you use the near hundreds trick where you multiply these together. So 3 times 2, write 0, 6, and that you get 6, so 0, 6. And then you write 100 plus each of these, so plus 3 plus 2 is 105. And you can imagine that as your like 100. I'll do proofs on things that I think people might just be inclined to memorize, but there's a very easy proof. You're basically just doing this. 2 times 3 plus 100 times 3 plus 100 times 2 plus 10,000. You know, 10,506. Okay, 46. This is a pretty hard one to visualize. Imagine this 19 over 22 as 22 minus 3 over 22. So if you multiply that, you get 16 minus 48 over 22 if you expand that out. And then you need to counteract that. So 13 plus 66 over 22. You subtracted 3 from your whole number to get 66 over 22 minus that 48 over 22. So then you have your 13 to start with. Then you have 66 minus 48 is 18 over 22, simplified to 9 over 11. And your goal is to figure out basically how many whole numbers do you need to take away to get a value that counteracts the negative value here. 47, if x is less than 0 and 2x minus 1 is 15, then x is equal to what? Well, if it's less than 0, that means that you take the negative when getting rid of the absolute value. So negative 15 is equal to 2x minus 1, x is negative 7. Sum of the roots is what? Sum of the roots is negative b over a in this case. So negative this value over this 1, negative 6. Okay, 3 and 3 over m times n and 1/3, it's equal to 12. So you got to think of it as 3 and 3 over m is like 3 point, etc. times 3 point, or sorry, something point another, etc. is equal to 12. Well, you can imagine then that 4 would be too high because that would get the fact that there's extra stuff here would get you a number greater than 12. But 3 is pretty close. 3 is the other closest. So your your n here is going to be 3. And now you have to convert this to an improper fraction, 10 over 3, and then move it over. So 12 over 10 times 3. You only need to worry about what's on the bottom, though, because that's what we're looking for here. So 12 over 10 simplifies to 6 over 5. So your denominator in this case is 5. So you just have, wait, why did oh yeah, because we're multiplying. 3 times 5 is 15. 50. This is clearly pretty close to 200 times 30. A little lower here, a little higher here. Close enough. 6,000. Done. Okay, you can rewrite this as 45 squared plus 46 squared. And now you can use one trick that a trick that's in the Brian Heath booklet that would take a while to prove. But basically, if this number, this 1, is greater than this 10 by 1, 4 is equal to 4 plus 1, and this 10 plus this 1 add up to 10, you can use the trick where you square each digit on this number, so 16 plus 25, and multiply it by 101. So you get 41 times 101, 41, 41. There's a very long proof that I did someday because I was bored. Actually, it's really not that long, but like, I'm not going to go through that. Definitely not on this video. Tens place out of the tens trick. Okay. That means we use 4 squared, right 16. And then you do 3 times 7 plus this 4, so 25. Okay, multiplying in different bases. Let's do it how you would multiply a normal number. This 4 times this 1 is 4, plus this 0 is 4. And then 4 times 3 is 12, plus 2 is 14, which in base 5 is 2, 4. So you have 2, 4 here. Okay, I have 3 plus 4i times 2 minus I is equal to that. Then what is A? A is the real part, so you use FOIL for anything that would become real. 3 times 2 is 6. And then 4 times negative 4i times negative I is negative 4i squared, which is negative 4 times negative 1. So 3 times 2 plus 4 times 1 in this case, so 10. Sum of Fibonacci, this is a Fibonacci series. What you do is 2 times this value plus 1 times that minus that. So you just do that. This is 508. And then I'd like to do the 157 minus 5. So you just have 508 plus 152, which is pretty easy to do in your head, 660. Measure of an interior angle of a regular pentagon is 180 degrees. What is the number of sides? Well, interior angle is, uh, this isn't my sign. Interior angle is 180 degrees minus 360 degrees over the number of sides. That value is 108. You can see that you need to subtract 72. See, 360 over x has to be 72. So you can hopefully see that that means x must be 5. Because 5 times 72 is 360. 72 over 2 times 10. Same thing as multiplying by 5, 360. Pentagon has how many distinct diagonals? Distinct diagonals of a polygon is side times side minus 3 all over 2. So 10 over 2, 5 times 7 is 35. 58, this is sum of alternating squares, which means your equation for that is your last term times 1 plus your last term, order of operations, is over 2 is equal to that 91 or negative 91. We can it'll be pretty, it doesn't really matter in this case what it ends with because it's not relevant to solving it. It's just like, if it's the last one is odd, if the last term on the alternating squares is odd, then it'll be negative. So do that. That multiplying 2, n times n plus 1 is 182. And as you can see, it's a little greater than 13 squared, a little less than 14 squared. This is clearly 13 times 14. N is 13. 12 power 25 divided by 13 as a remainder of what? Okay, in this case, you use another trick that I don't know the name of, where you take the number, figure out the number of relatively prime nums to 13. Since 13 is prime, everything but itself is relatively prime, so 12 relatively prime numbers. So then you take your original 12 power to your original exponent mod, or the remainder when divided by this 12. So you have 12 powered to 1 is 12. This, okay, only parts that really matter. 35 times 11. 35 times 11, use your 11 tricks and you get 385. 385, and then you realize this is like a third of this. So you have to take away, since this is so close to 1 plus 1 and something, you have to take away a digit from this. So your number should have 1, 2, 3, 4, 5, 6 digits. And as you can see, 6 digits right here. Okay, this you'll be rearranging things. 4 times 5 factorial is equal to 20 times 4 factorial. And then 20 times 4 factorial plus 5 times 4 factorial divided by 4 factorial. Each of this stuff canceled out. You just have 20 plus 5 now. 25. 62, square root of 20 plus square root of 45 is equal to square root of x. Then x is equal to what? Okay, in this case, you'll be taking out 2 squared from this and writing 2 at the beginning. So now you have 2 square root of 5. 3 squared can be taken out of this, so plus 3 square root of 5 is equal to 5 square root of 5. And then you have to put your 5 back in. So multiply your interior value by 5 squared, and you get 125. The harmonic means of the roots. Harmonic mean of the roots, there's a proof for this in the Brian Heath booklet, but basically take negative the last number, multiply it by this exponent right here, so 6 times 3, divide by 11, and you get 18 over 11. Now log base 3 of log base 3 of 27, well, log base 3 of 27 is 3, log base 3 of 3 is 1. If f of x is equal to 3x and g of x is equal to x plus 4, then g of f of 2 is what? Just plug in your values. G of 6, 10, you got it. 66 will be using a very special formula for given this exact piece of information. In this case, it's plus, so you'll be subtracting 3 times that when we do it. But the equation is you square this x plus y, you get 25. You subtract 3 times this value, you get 19. Then you multiply by 5, 19 by this 5 again. 19 times 5 is 95. Okay, this will be multiplying by 11's trick, except now you're doing it in base 4. So you do your 1 times 3 to represent this your 1's digit. Then you do then we'll be ignoring the 1 times part for now. 3 plus 2 is equal to 5. So 1, and then you carry over a 1. 2. Did I write this wrong? Hold up. No, I did. Well, I wrote this wrong. So 2 plus that 1 you carried over is 5. Carry over a 1, right? 1 left over. And then you just have your 2 plus 1 left. 3, 1, 1, 3. Middle term of this expansion is that, sum of p, q, and r. The middle term is the x squared y squared term. Or in this case, it's just the x squared term because there's no y attached. Hold on. Oh, this is actually I just realized this. This is actually an error. There's no y squared. There's no y squared. Wow, that's hilarious. It actually is 26, but I think they just forgot to write the y here. I'll tell you what to do if there was a y there. So there's actually an error on the test. And I don't think anyone ever realized that because everyone already knew what to do here. If you're on 68, you already know how to solve these problems generally. So the middle term is your x squared y squared term. So you have to square this value, multiply it by this value squared, or coefficient squared, to represent the x squared and y squared. Then you multiply it by 4 combination 2. If you don't know what combination is, it's basically this factorial over this factorial divided by this minus that factorial. So 4 factorial, 24, divide by 2 factorial, 2, divide by 2 factorial, 2, all to get 6. So you basically just have 2 times 2 times 6. And then you have to add your 2 that represents 2 and 2 that represents Q and R. 69, this is a sequence where each term is the previous plus 4. B is 18, D is 22. Moving on. Cube root of this number, since it's cube root, you'd put in groupings of 3. This is a group of 3. This is a group of 3. This is slightly more than 3 cubed, so like 32. And then the 3, 2, 0, basically. The area of the ellipse is k pi. Find k. Area of an ellipse given this stuff is the square root of this value divided by that, multiplied by this value over that. So 16 over 8 is 2, times 16 over 2 is 8. 2 times 8 is 16, square root of that is 4. 8 is your radius, pi over 2. These are polar coordinates. Basically, to get x and y, you do this, multiply it by cosine of this value to get x. So cosine of pi over 3 is 1/2, times 8 is 4. Limit as x approaches 4, this stuff right here, since this would create an indeterminate form, 0 over 0, which means you have to use L'Hospital's rule, which is a calculus thing. Take the derivative of the top and bottom. 3x squared over 1 is, when you plug in 4, is 48. Change this to a base 6 decimal. Well, you got to imagine how you do it is you first got to figure out how many 6's go into 11. Well, 1 does. So your first digit is going to be 1 in this case. And then how many 1's go into what do you have left, which is 5? Well, 5. So your answer is 1, 5. And then you can imagine, basically this represents the 1 over 6. So to get that, you'd have to divide the numerator and denominator by 6. So that's why you're figuring out what number times 6 is it gets you to 11. F of x is that, and f of negative 1 is what? Okay, f of negative 1 of 2 is what? Okay. F negative 1 of 2 means you plug in your 2 right here and solve for this x. So you just do that. Negative 2, multiply by 4 to get negative 8, subtract 1 to get negative 9, divide by 3 to get negative 3. This, take the integral, you get x powered to 4 over 4. And then you simply plug in your values. You use your, you know what, yeah, if you're getting here, you should know how to do an integral. So yeah, 1 over 4 minus 1 over 4 is 0. 3 coins are tossed. What's the probability of not getting ahead? Uh, okay, 3 coins are tossed. Probability. So the probability of not getting a head is the probability of getting tails 3 times in a row. So 1 over 2 times 1 over 2 times 1 over 2 is 1 over 8. 78, this is your cubed. So you got to use a special kind of logic thing here. So for you'll be doing this in pairs of 2, basically. Because there's a 0 here, you can afford to do that. And you're basically multiplying ones and hundreds, so the tens term is disregarded. And all, iterations of it, I suppose. So what you do is, for the ones place, you take the ones place, powered to 3, and then multiply it by, and then you just keep it like that. Or if you want to get more technical, multiply it by 3 combination 0. And 0 factorial is 1, by the way. If you remember how combinations work or just already know it, you should understand what I'm doing. Then for this one, you have 100ths term added in. So 1 squared times 3 powered to 1 times 3 combination 1 gets you 9. So 0, 9. Now you're on to this, or this stuff right here. So now you're using 200. So this 1 times 3 squared times 3 combination 2 is 27. And then finally, for the last one, you're having this hundredths place cubed. So 27 times 3 combination 3, which is just 1, 27. And there you go. Okay, 79, the third non-agonal number. Basically, numbers that like this, imagine this as a number of sides, basically. Or I guess and this, just here. You multiply it, first off, what you do is you multiply this 3 by the number of sides this represents, so 9 minus 2. So 3 times n minus 2 is 21, or 3 times 9 minus 2 is 21. And then you subtract it from this minus 4. So subtract 5 in this case, 16. And then you multiply it by this number again, 48, and then divide by 2. It's easier to divide by 2 first, 16, 8, 24, but whatever way works for you. 80. This is 70 over 9 because 7 over 9 would be this divided by 10 if you move the decimal over. So 70 over 9 times 18, 70 times 2 is 140, and then multiply by 100 or 10 to get 140, 140 and 2 zeros. Okay, that was the entire test. I covered it for 40 minutes, which means I hopefully gave enough time for each problem. If you want any more in-depth explanations or any proofs, please either ask me in person or leave a comment. I kind of wish I could do more proofs while doing this. I think they're the best way to really learn the data and not forget them. But yeah, if you want any of that, ask me in person. Ask Ivan if he's still there and I'm gone. Or just ask your best number sense person after we're gone, or if someone else rises to beat us.